Hey, Transmath 2 class, we are going to continue on with notes for section 2.8. So, what we're going to look at in this section is going to be more adding and subtracting, a little bit fractions, but what we're going to do with some of these is, last time we had common denominators given to us. Some of these we might have different denominators, so what we're going to work on is finding some equivalent fractions, which we did a bit in the last section, and specifically what type of equivalent fractions will allow us to add these fractions together. Okay, so to review making equivalent fractions, we want to look at what they've given us, 5 over 5, and then we're going to multiply those 5s each by something to make 15s, and hopefully you know that that's going to be a 3. So we put 3 in each box. And next one, we got 6 over 8. We want to change the 6 to a 12, the 8 to a 16, so hopefully you know that you multiply each of those by 2. And remember, it's always the same number so that you make equivalent fractions. Multiply the same number on the top and on the bottom. Okay. All right, so next one, we're going from 3/4 to 18/24. So we want to say 3 times what is 18 and 4 times what is 24. So hopefully we know that that is 6. 3 times 6 is 18, 4 times 6 is 24. All right, continuing on here. So now they've kind of just given us the choice to make whatever kind of equivalent fraction we want. So I'll just pick some numbers just as long as they're the same on the top and on the bottom. So if we go 2's here, 10/4 would be equivalent to 5/2. Let's say I go 3's here. 3, 1 times 3 is 3, 8 times 3 is 24. So 3/24 would be the same as 1/8, equivalent. And if I go 4's here, 6 times 4 is 24, and 8 times 4 is 32. So 24 over 32 is equivalent to 6/8. Okay, so show how locating 3/5 on the number line is the same as adding 1/5 3 times. Well, basically what they're saying here is, if we can see we have 5 fair shares here, right? So 1/5, 2/5, 3/5, and 4/5. So if I were to add 1/5 plus 1/5 plus 1/5, it puts me right here at 3/5, okay? So our power concept states that if denominators of a fraction of the denominators of the fractions being added are the same, add the fractions by adding the numerators and using the same denominators. So for example here, 3/6 plus 1/6, again we add the tops, 3 plus 1 is 4, leave the denominators the same. So 1/5 plus 2/5 would be 3/5. Okay, now they're going to throw an example at us where we're adding fractions that have different denominators. So these ones are just a little more work. The only way that we can add these fractions in the way we have been is if the denominators are the same. So that means we have to transform one of them, or sometimes both of them, so that the denominators are equal. Okay. They just kind of throw out an example here. They say, well, what if we had 2 cakes at a party, and afterward there was 1/6 of the cake with the black icing and 1/2 of the cake left that had orange icing, they said. If you put those two together, how much would you have? Well, let's take a look here. What we need to do in order to add those fractions, 1/6 plus 1/2, right? 2 different denominators, 6 and 2. So what we want to do is, they're helping us out here. In order to do this, we want to transform this 1/2 so that its denominator is a 6. So we got to ask ourselves, what do I have to do with that 2? What do I multiply it by to make it a 6? And they kind of show us. If we go 2 times 3, then that's going to be a 6. And we'll make an equivalent fraction as long as we take the numerator by the same number. 1 times 3 then is 3. So if we have 3/6 plus 1/6, now we can now do that problem. So 1/6 here, the 1/2 we said was equivalent to 3 over 6. So now I can add 1/6 plus 3/6 is the same as 4 over 6. Okay, so in order to add fractions, you must have the same denominators or common denominators. Okay, so that's what we're going to practice doing. Now here they start us off with some that already have common denominators. 2/6 plus 3/6, we just add the 2 plus 3 and we get 5. Leave the denominator as a 6. Remember, that always stays the same. And you don't have to use the number line necessarily. Okay, here they're going to help us out a little bit. So our question is 3/10 plus 1/5, they're different. So what we need to do is change the 1/5 so that we get it. What we need is a 10 on the bottom, right? So we'd have to take 5 times something to get 10. That's going to be a 2. Got to do the same on the top and on the bottom. So 1 times 2 is 2. So instead of 1/5 here, I would cross that out, and I would say I want to write that as an equivalent fraction of 2/10. So now I can add 3/10 plus 2/10 would be 5/10. Okay, so that's how we're going to do that. And usually you're going to take the smaller denominator, multiply it by something so that it's equal to the larger denominator. So here, the 1/2, right? We need to change that 2 into an 8. So what do I multiply 2 by to make it 8? That would be by 4, right? And again, same on the top and on the bottom. 2 times 4 is 8. 1 times 4 is 4. So instead of 1/2 here, I'm going to write 4/8. So 3/8 plus 4/8 would equal 7/8. Okay. So this next set of problems, it looks like we have common denominators on each of these fractions. So pretty straightforward. 1/2 plus 1/2 would be 2/2. 2/6 plus 3/6 would be 5/6. And 1/8 plus 4/8 would be 5/8. Okay, so those ones all had common denominators. Now, the next set of problems, we have to create equivalent fractions. So we're going to have to multiply by something on both the numerator and the denominator. And so we just have to decide what that's going to be. And so in the first one, we have 1/4. And we're adding to that 2/8. So we need to change that 4 into an 8. So we're going to multiply by 2. Top and on the bottom. So 1 times 2 is 2. 4 times 2 is 8. Okay, so now instead of 1/4, I'm going to say that's equivalent to 2/8. So 2/8 plus 2/8 would be 4/8. Now I can add those together. All right, so all we do is add the numerators once we make our equivalent fractions. Number 2. So this 1/3, we want to change that so that the denominator is a 9. So I'm going to take the numerator and the denominator times 3, because 3 times 3 is 9. 1 times 3 is 3. And so now, instead of 1/3, I can call that 3/9. 3/9 plus 1/9 is 4/9. Okay. Next one, we've got 3/10 and 1/5. Okay. So we want to change that 5 into a 10. So if we multiply by 2 on the top and on the bottom, 1 times 2 is 2. 5 times 2 is 10. So now instead of calling it 1/5, equivalent fraction would be 2/10. 3/10 plus 2/10 would be 5/10. That would be my answer. All right. Next one, I've got an 8 and I've got a 2. All right, so I need to change that 2 into an 8 by multiplying it by 4. So 2 times 4 is 8, and then I have to take the top times 4 as well. 1 times 4 is 4. So now instead of calling it 1/2, I'm going to call it 4/8, equivalent. And 3/8 plus 4/8 equals 7/8. Okay, 3 plus 4 is 7. Next one, so we've got a 6 and a 3. I'm going to change that 3 into a 6 by multiplying it by 2. So I have to multiply by 2 here on the bottom and on the top. 2 times 2 is 4. 3 times 2 is 6. So now instead of having 2/3 here, my equivalent fraction is 4/6. So I'm actually adding the same two numbers. 4/6 plus 4/6 would be 8/6. Okay? All right, so now here are a few word problems. It says Hector works for the city and he puts pipe under roads. The pipes carry water from rain. He and the other workers dig a trench and put in the pipe, cover it with dirt, and pave the road. The pipe is 1/4 unit wide. The dirt is 1/2 unit deep. How many units is it from the bottom of the pipe to the street? Okay, so it said the pipe was 1/4 unit. The dirt was 1/2. So to figure out this full distance, I'm going to have to add those together, right? So 1/2 plus 1/4. Now the problem here is they have different denominators, right? Now I want to change this 2 so that it's a 4. I want to make it a 4. So to make an equivalent fraction, I'm going to go times 2 and times 2. All right, and so 2 times 1 would be 2. 2 times 2 would be 4. So an equivalent fraction there would be 2/4. I'm just going to carry down this 1/4 again. So the 1/2, I change that into 2/4 by multiplying by 2 on the top and on the bottom. and now I can add them. 2 plus 1 is 3, so it's equal to 3/4. Okay. All right, the drawing of the house is shown here. When the length of the front of the house is measured, it's 6/10, so this is 6/10, and then the side is 2/5. What's the combined lengths of the front and the two sides? What's the combined length of the front and two sides of the house in this drawing? Let's see. Well, let's just go with the combined length of the front and the side here. They didn't really show us, because we would assume that both sides are the same, but let's just add together these two for this problem. Okay, so we're going to have 6/10 plus 2/5, right? Now, again, the denominators are different, 10 and 5, so we need to multiply the 5 by 2 so that we can make it a 10, and we need to do the same on the top and on the bottom. So I've got 6/10 plus 4/10, and if I add those together, now I've got 10/10. Okay, so I'll have 10/10 units. Did they give? Yeah, they just said units. Okay, so again, different denominators, you need to make common denominators. All right, next picture, it says this cat's face is supposed to be drawn proportionally, but the eyes are not exactly centered. The width of the cat's face from the left to the center is 3/8, and from the center to the right side is 1/2. What's the total width of the cat's face in the drawing? So we have to add together 3/8 plus 1/2. So we're getting a total length all the way across. Now, again, different denominators. So the 2 has to change into an 8. We have to multiply it by 4 to make that an 8. And so, again, same thing on the top and on the bottom. I'm going to carry the 3/8 down again. And then 1 times 4 is 4. 2 times 4 is 8. Now I can add those fractions together, and I would get 7/8. Okay. And the last one. This drawing shows an old human skull. A scientist wants to know the total distance from the back of the head to the front of the teeth. The scientist makes measurements as shown. How many units is it from the back of the head to the front of the teeth? Okay, so they kind of did it in two parts, from the back of the skull to kind of like the jaw here, 3/4 inch, 3/4, and then from the jaw to the front of the teeth was another 1/2. So we're going to add those together, 3/4 plus 1/2. And we're going to multiply, because we need to get a common denominator of 4. This has a 2, so let's multiply it by 2 on the top and on the bottom. So 3/4 stays the same, and then 2 times 1 is 2, 2 times 2 is 4, 3/4 plus 2/4, 3 plus 2 is 5, so we would get 5/4 units. Okay, so that's adding fractions that have different denominators. Make equivalent fractions by multiplying by the same number on the top and on the bottom so that you get common denominators. Then you can add the numerators. So that's it for 2.8.